Thus far, we have looked at substitution and elimination as methods of solving systems of equations. Those are called algebraic because you're doing algebra. You're, substituting, solving, back substituting. There's another method called graphing that can also be used to solve systems, and quite frankly, it's my favorite. It's one of the easiest to use. So here's how it goes. You graph both equations. So, for example, let's imagine here that one equation is the red. So every point on the red line is a solution to the red equation. Every point on the blue line is a solution to the blue equation. So if I'm looking for an ordered pair that's a solution to both, I want to look at where those two lines meet each other. So you look at the intersection and then check and make sure that answer works out. Let's see how it goes. All right, you are going to have a practice sheet in addition to your book problem, so make sure you give it a look. Here are two equations. We have a system. Now, it doesn't matter what form the equations are in. Now that it's the 21st century, your Desmos will graph an equation in any form. So that's what I'm going to do. I'm going to pull up my Desmos and just type this in exactly like it looks. So negative 42 minus 3y equals 8x. Okay, so here it is. I'm going to make it red. So every point on the red line is an ordered pair that makes this equation true. There's lots and lots and lots of them. Okay, now let's put in a second equation. So our second equation is 6x equals 90 minus 9y. Okay, so here in purple, I think I'm going to switch it to blue actually. In blue, every point on this blue line is a solution to that blue equation. So what I want to see is, hey, do these two lines cross each other? Let's take a look. Let's take a look. Sure enough, they do. That means that the solution to the system, the ordered pair that makes both equations true, is negative 12, 18. I hope you can see why I like this method. It is quick, it's efficient, and there's not a whole lot of work that needs to be done. And as a lazy mathematician, I like that. Okay, there it is. Next up, the equation here is hidden under an animal called a quokka. I don't know if you've heard of this. It's got a face that always kind of looks like it's smiling. I don't know whether it's actually a nice animal or if it's dangerous, but there you go, my picture of a quokka. Here's my favorite thing about graphing. Even when the equations are a little bit nasty looking, like this top one, for example. There's nothing wrong with fractions, but they're harder to work with. The graphing method still works just as easily and efficiently. So 2 over 187x equals 1 plus 1/17 y. So just going to graph this whole equation. Equals 1 plus 1/17 y. Okay, so here it is down here. That's my new red equation. So for example, if I put a 0 in for the x up here and a negative 17 in for the y, I get a true statement. Any other ordered pair on this red line makes that red equation true. Now let's adjust our blue equation. 22y equals 22 minus 32x. 22y equals 22 minus 32x. Now, the only drawback to graphing is you got to make sure that you've typed everything correctly. So I'm just going to do a quick double check. So 22y equals 22 minus 32x. Okay, all right. Now, as I'm looking here, I see that I do, in fact, have an intersection. So every point on the red line solves the red equation. Every point on the blue line solves the blue equation. So the point that solves them both is going to be this one right here at the overlap, the 11, negative 15. So 11, negative 15. And there you go. You've solved your system. So going forward, unless you're specifically told which method to use, You can use any method you want, substitution, elimination, or graphing. And most of the time, I'm going to choose graphing.